multiplication of fractions. How do you multiply two fractions? In multiplying two fractions is straightforward after you reduce. The first three columns, it will have no reducing involved. You multiply the top numbers. 2 times 4 is 8. 3 times 5 is 15. You say that wasn't there. You are asked to multiply 7 over 6 by 5 over 8. 7 times 5 is 35. 6 times 8, 48. Done. You were asked to multiply 8 over 3 by 7 over 9. Just two multiplication problems. 8 times 7, 3 times 9, problem's done. You were asked to do 3 over 7 times 2 over 5. You would get 6 over 35. 3 times 2 is 6. 7 times 5, 35. You have 7 over 6 times 9 over 7. The two top numbers are 7 and 9, and the two bottom numbers are 6 and 7. Can you think of any number other than 1? Can you think of any number other than 1 that goes into one top number and one bottom number? The answer is yes. 7 goes into both of those numbers, one from the top, one from the bottom. Into the top number one time and the bottom number one time. 3 goes into both of these numbers. You need to know your 3 times table. 3 goes into 6 2 times, and 3 goes into 3 one time. With respect to the remaining top numbers and the remaining bottom numbers, is there a number other than 1 that goes into a top number and a bottom number? Well, the only number that goes into 1 is 1, but we don't want to divide by 1. Because if you divide by 1, you get back the same number. The only number other than 1 that goes into 3 is 3. 3 doesn't go into 2, it doesn't go into 1. That is, we can't reduce anymore. You multiply the remaining top numbers, you multiply the remaining bottom numbers. The answer is 3 over 2. You could have, and I definitely don't advise this, you could multiply the 7 by the 9 and the 6 by the 7, and then you have bigger numbers. I dealt with 1s and 3s and 2s and 1s in the first case. Nothing bigger than 3. Now we have 63 and 42. You need to know your times table. You need to know that 21 goes into 63 3 times, and it goes into 42 1 time. And there's your 3 over 2. If you didn't see 21, you can say 7 goes into both of those numbers. 7 goes into the top number 9 times, and goes into the bottom number 3 times. It's a lot easier to just say 7 goes into 7 evenly. Now, 3 goes into both of these numbers, 3 and 2 times. Well, that's exactly what we had here. We didn't have to multiply by this 7. Now, I want to talk about one other thing. For some reason, students think, for example, if you have, I don't know, 5 over 15 times 25 over 2. don't think you can reduce from top to bottom. It always has to be on a diagonal. This is not true. Even if it were true, the top is 5 times 25 over 15 times 2. Well, 5 times 25 is the same as 25 times 5. The bottom is 15 times 2. And this does equal, and we'll make sure it does, this equals 25 over 15 times 5 over 2. After all, 25 times 5 is the top, and 15 times 2 is the bottom. It is equal. Oh, now I can reduce the 5 into 15. Well, the point I'm trying to make is you can reduce it even if they're underneath one another. Any top number, any bottom number, you can reduce. They don't have to be on different fractions. 5 goes into the top number 5 times, and into the bottom number 3 times. With respect to the remaining top numbers and the remaining bottom numbers, you can't reduce anymore. 1 times 25 is 25. 3 times 2 is 6. The answer is done. Now, how you reduce is not unique. 2 different students can do it differently. One student can say, oh, 5 goes into both of these numbers. One from the top, one from the bottom. 5 goes into 15 3 times. And 5 goes into 25 5 times. Can't reduce anymore. The only numbers, for example, that goes into 3 is 3, and into 2 is 2. But 3 nor 2 goes into the top numbers. 3 doesn't go into 5. 2 doesn't go into 5. 5 times 5, 25. 3 times 2 is 6. We did the reducing differently, yet we got the same answer. How you reduce is not unique. The answer that you get is, that is, you must get, if 2 different students, or if you do it 2 different ways, the 2 different students, your 2 methods must have the same answer. You have 5 over 3, and you multiply by 21 over 7. Well, we'll do this 2 different ways. You can say 7 goes into both of those numbers. One from the top, one from the bottom. 1 time, 7 goes into 7 1 time, goes into 21 3 times. Well, 3 goes into each of those numbers. 1 from the bottom, 1 from the top. Goes into 3 1 time, and into 3 1 time. And you're done. The answer is 5. 5 times 1 is 5. Divided by 1 times 1, which is 1. The rule for dividing by 1 is, don't do it. It's just 5. Okay, let's do it again. Instead of saying that 7 goes into 7 and 21, we can say 3 goes into both of those numbers. 1 time and 7 times. With respect to the remaining numbers, 7 goes into both of them. 1 time and 1 time. We're left with 5 times 1. We can't reduce anymore. 5 times 1 is 5 over 1 times 1, which is 1. The rule for dividing by 1 is don't. Just get 5. And yes, we got the same answer. We did it 2 different ways, but yet we get the same answer. You have 42 over 6, and you're multiplying this by 35 over 14, and you multiplying that by 4 over 10. To do this problem, Sometimes there can be as many as 10 different ways of doing it. One way is to say 6 goes into both of those numbers, 1 time and 7 times. And you can say 7 goes into both of those numbers, 1 time and 2 times. And then you can say 2 goes into both of these numbers. Or you could have said 2 goes into 4 and 10. Could have said 2 goes into the 10. But I did it. 2 goes into 2 1 time, 2 goes into 10, 2 goes into 4 2 times. Now, 2 goes in here 1 time, 2 goes in there 5 times. And then I guess the answer is going to be 7, because 5 goes into both of these numbers 7 times and 1 time. 1 times 7 times 1 is 7. Multiplying by 1 doesn't do anything. It's just 7. 1 times 1 times 1 is 1. Don't divide by 1. Won't get you anything. The answer is 7. Okay. You can say both of these numbers are even, so 2 goes into both of them. You can now say, oh, these two numbers are even. 2 goes into both of them. 21 times and 5 times. You can say, oh, 3 goes into both of these numbers. 1 time and 7 times. You can say, oh, 5 goes into both of those numbers. 1 time and 7 times. You could say 7 times 2 is 14, and that kills off the 14 in the bottom. But we'll do it in 2 steps. This 7 and this 14, 7 goes into both of them. 1 time and 2 times. 2 goes into both of those numbers I crossed off. 1 time and 1 time. The answer is 7. 7 times 1 is 7. Times 1 is still 7. And we're dividing by 1 times 1 times 1, which is 1. Don't divide by 1. It won't get you anywhere. Okay, so we did that problem a couple of different ways. 2 different ways. But we got the same answer. Remember, 5 divided by 1 is 5. 13 is 13 divided by 1. 11 is 11 divided by 1. 124 is 124 divided by 1. So, somebody asks you to multiply 10 by 2 over 5. If it makes you happy, you can say, oh, that's over 1. If it's not going to make you happy, then don't see it. Don't do that. 10 times 2 over 5. The 10 and the 2 are the top numbers. The 5 is the only bottom number. 5 goes into this top number and that bottom number. 2 and 1 times. The bottom is 1 times 1, which is 1, which means we won't even write it. And the top is 2 times 2, which is 4. If you didn't write the 1, 10 over 1, you just wrote 10. Again, 10 is the top number. 5 goes into both of those numbers. 1 on the top, 1 on the bottom. 5 goes into 10 2 times. And 5 goes into 5 1 time. We're dividing by 1. Don't do it. 2 times 2 is 4. This 2 times that 2. 4. If you were asked to do 20 times 20 over 4, well, 4 goes into 4 and 20. 4 goes into 4 1 time. Goes into 25 times. 5 over 1 is 5. 20 divided by 4 is 5. So it's 10 times 5. 10 times 5, 50, divided by 1, which I won't do. 7 times 2 over 3. You want to see a 1 on the bottom? It's there. The only number that goes into 3 is 3. 3 doesn't go into any of the top numbers. The problem is done. 7 times 2 over 3. Or, if you prefer, 1 times 3, which is 3. I want to do one last problem, show you that you don't get anywhere by dividing by 1.